So okay, okay, uh, 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 data succession algorithm lab experiment number 9. So in this lab, we're actually asked to implement few sorting algorithms, namely insertion sort and selection sort. The first one was a selection sort, then I have insertion sort. First, before going into the code, I'll just show you the output. Okay, as you can see here, it's asking which algorithm you want to use. First, I'll say I want to choose a selection sort. We have 5 elements in the array. Then 5, 4, 3, 2, 1. As you can see, it sorted the array and gave it to me. Then, sorry, first was selection sort. Second one was insertion sort. Sorry, there's a small error here. Mm, yeah. Uh, Second one was insertion sort. Just a small error for printing the menu. I'll show it to you once more. So for selection sort, 5 elements, 5, 4, 3, 2, 1. So 1, 5, 14, 42. The next insertion sort. So for this, I'll say 8 elements. 1, 3, 4, 5, 6, 7, 8. So if you see 8 elements were there, it's ordered in the right order. And I'm exiting the okay. And now let me go to the code. So first thing was the selection sort function. Okay. So selection sort is basically finding the minimum index at that particular point. Say for example, for 5, 4, 3, 2, 1, selection sort is basically finding the minimum element in all this and replace it in the first position. So this will become 1, 4, 3, 2, 5, and then this will become now find the minimum element with the unsorted part. This one here is already sorted in the unsorted part and replace it in the first position. So the 1, 2 is the next minimum element, and 3 and 5. The same way now in this unsorted part find the minimum element and replace it. 3, 4, 5. Again, until the last thing this happens, the time complexity for this will be O of n square. As to find the minimum element, you would actually require to go a search of O(n). So O of n square. So first I have a for loop up to n minus 1th element. Then I have this min index and I search for the minimum element and update this min index. If this min, uh, if the current j is less than the minimum element, update the index of the minimum element. Then after finding the minimum element, I swap it with the current position of I, and I swap the I swap the element in the current position and the element in the min index. So that is done. This is how the algorithm works. And after that, we have insertion sort. Okay. So So for this, what we actually do is basically uh, we have a sorted part and we have an unsorted part. 3, 5, 4, 3, 2, 1. Okay. First element by default we make it into the sorted part. Okay. So first I start with I is equal to 1, so that I have this barrier in the first element. Then what I do is I make j will be equal to I minus 1. That is the element previous to the current type. So so this barrier will be there uh, before the current type. Okay, so this part is sorted part, this is unsorted part. Then I take the current I and I store it in a variable called d. Okay, and then I check if the current if the current j and the current I. So if the current I is less than the current j, what I do is I copy the current j to the ith position. So this becomes like this, and then I decrement j. So j will become, first j was 0, now j will become 1. Okay, and then I'll check. Okay, so j will become minus 1. Okay, and then this while loop ends, right? So after that I'll just make the air of j plus 1. So until this is greater than equal to 0, this will go on, and the jth element is greater than the e. So this will be minus 1. So after this I just make the air of j plus 1 as e. So e was 4, if I remember. Now what happens is this bar will go here. This is a sorted part, this is unsorted part. Now j will be 1, I will be uh, I will be 2. Okay, so now E will also be 2. So I will be 2, E will be 3. E will be air of I, so will be 3. So I'll check if this element is less than air of J. So at the first position, yes, it is less than. So I copy air of J to air of J plus 1. And then I decrement J. Okay, and I check again if this element is less than this element. If it's so, then air of j plus 1 will be uh, equal to air of j. I just copy this and then I decrement j. Now this condition fails, so I just make air of j plus 1 is equal to e. So e was 3. Now this dot goes here. So I'll just make a small change here. What if here it was 1 and here it was 2? Okay, start to so that you can easily understand this condition. So now j would be 2, I would be 3, e would be 1. Now we'll check if air of j is less than the element at e. Yes, so copy 5 at air of j plus 1. Same thing we'll check, 4 will be copied here, then 3 will be copied here, then uh, at this point will be minus 1 and make this as 1. Now the bar goes here. Now E J will be 4 or 3, 4, E will be 2. Now same thing happens. Checks this 5, copies here, so copies 4, copies 3. When it comes to this here, they become uh, 0 technically. When it comes to here, if you see, okay, element at this condition will say air of j is greater than 0. A of j is, if this is a of j is less than 0, so this condition will fail. That we can say a of j plus 1 will be e. So this will become 2. This is how this instruction sort will work. Now I go to the main function. This is to print my identity that this code belongs to me. This is to print the menu for choice, and picking the choice. I have n variable n and the temp variable. This is to store the number of arrays, uh, number of elements in the array. This is to store some value. So while choice is not equal to 3, this will be executed. The control will remain in service. Now I just ask the user for total number of elements stored in n, and I ask the user to enter the elements in linear order and then store it in this array pair of n. And depending on the choice of the user, with one I'll call selection sort function, and then uh, I'll pass the array index and this is passed by reference. So whatever change this does will affect the actual value. Then I just print the sorted array. If it's case 2, same thing with insertion sort. I just call insertion sort function. Anything other than 1, 2, or 3, default will be activated. Then again I then again I print the menu and ask the user for a choice and store it in choice. If the user enters 3, will exit, otherwise again will go. So that's it for this program. Thank you for listening, for watching.